The purpose of this video is to demonstrate how to connect your computer to a new Brunswick CelliGen or BioFlo Bioprocess system and how to use the BioCommand software package to create a recipe and a batch. Before making any hardware connections, be sure that the BioCommand software is properly installed on your PC according to the operating manual provided with the software package. There are three parts to the software: the OPC Server Wizard, the OPC Server Test Client, and the BioCommand program itself. First, connect the provided RS-422 cable to the BioCommand serial port on your controller. Then, connect the other end of the RS-422 cable to the 6-inch BioCommand light cable. The other end of the 6-inch light cable connects to a RS-422 RS-232 converter, which is also provided with the kit. The converter connects to an interface box, and the interface box then connects to the USB port of the PC. The interface box converts up to 8 RS-232 COM ports to USB for customers whose computers lack RS-232 connection. To use the interface box, you will need to install the software that is supplied with the interface software package. It is very important that all three cables are connected in the proper order, otherwise the software will not be able to communicate with the controller. In order for BioCommand to share information with each of the attached controllers, three essential pieces of information must be provided to the software: the controller protocol, which communication port is connected to the controller, and the unique ID number of each controller. To obtain the ID number and the controller protocol, click on the Setup button at the bottom of the controller's main screen and then click on the Hardware Setup tab. The unit ID and the protocol mode will be displayed on the left side of the screen. Open the NBS OPC Server Wizard. When the program window opens, click the Next button to display the main window. Click Search to add new controllers. When the search window opens, click on the Search On drop-down arrow and select the appropriate communication port. Then select the protocol that your controller is set to by clicking on the appropriate option button. Set the ID range you wish to search and then click Search. Select the controller you wish to connect to from the search list and click the Finish button. The main window is now displaying the selected controller with an active status. Click Save and Close to exit from the main window. The OPC Test Client is a program which gives users the ability to test the controller's communication with BioCommand. To test your connections, click and open the OPC Test Client. Based on your previous selection, select either AFS or Modbus from the drop-down menu, then click on the Connect button. Click on the plus sign next to the folder to reveal the available loops for that device. Click on the data from the loop you would like to test, then, in the pop-up window that opens, click on the Add to Refresh Group button. The data is now added to your test group. The information from the test client indicates whether your fermentation hardware is communicating with BioCommand. A bad connection or loss of connection will result in an error message and a bad quality message. Check all connections. If a bad or error connection is detected, run the OPC Server Wizard again before attempting to re-establish communication. A recipe is a process description that BioCommand uses to control a fermentation or cell culture process. A recipe is a template that dictates how the process will proceed. Recipes include initial set points for controlled parameters such as temperature, pH, dissolved oxygen, trends, alarms, etc. To create a recipe, open BioCommand and then click on New Recipe. First, you will identify the new recipe with a name, and you will select a folder in which to save it. Click Next to go to the next screen, and then click on Select Loops. In the left-hand panel, the OPC servers that are available for the system are displayed. Click on the plus sign next to the one that corresponds to the COM protocol you will be using. Click on the plus sign next to the controller you will be using to open the list of available control loops. Click on the Save and Close button when you are finished adding loops to the recipe. Click on Create Program to create a program for your process. BioCommand has powerful programming tools that can alter set points automatically at specified times or when specified culture conditions are met. Users can create programs using functional blocks which include logical, mathematical, and user-defined functions or advanced Visual Basic programming. Synoptic is a feature which allows users to create a pictorial overview for their process. Click on Set up Alarms to create alarms for your process. When you click on the Create Trend button, the trend screen will open to allow you to plot loop activity over time. Recipes can only be edited before they are used in a batch. After that, you can only make changes if you copy the recipe and give it a new name. So be certain to make final edits and then click the Finish button in the Recipe Wizard screen. Batch refers to a specific fermentation or cell culture run. Every batch starts from a recipe. The same recipe may be used over and over to run several batches. Before starting a batch, prepare the fermenter or the bioreactor. Click on the New Batch button to start creating a batch. When the new batch window opens, enter a batch name and description. Then select the recipe, a location for the batch to save, data log interval, and time display format. When all of the required information is provided, click Start Batch. The batch is now running, which is confirmed by the green highlight on the batch name in the Batch Explorer panel. Multiple batches can be run at the same time. This concludes our demonstration on how to connect your computer to a new Brunswick Bioprocess system and how to use BioCommand software.